So after drawing, my line y equal to negative x minus 3 and then y equal to negative x squared plus 3, then we got, a line and parabola intersecting at 0 and 1. And then that help us to see here's the region bounded by the graph of these two equations. And what we are interested in is find out the area of this region. So when we talk about the area of these regions, then what we're gonna do is we're gonna look at, this is very important part, are we gonna be placing our little rectangle vertically or our rectangle in horizontally to find out the height of the rectangle, right? Because there's a formula, the height of the rectangle we need to look for. And basically, this is very important because if you place it vertically, what happens is each rectangle is going to be lined up like this. So the width of a rectangle is delta x, which is dx. If you're placing the rectangle horizontally, then that's basically talking about the width of each rectangle will be delta y, which is going to be what? dy. So that basically means if you are using dy, then your limit must be on the y-axis, y value. If you are using dx of the integral, right, the integrating respect to x, then your limit must be on the x-axis, right? So your x value. So it's very important that you need to decide it's going to be vertical rectangle or horizontal rectangle that you're going to be visualizing to find out the area of this regions. So is there any questions before I move away from here? So looking at the bigger picture of this, this portion, this shaded region that right here, now we're going to be looking at our rectangle. We're going to be placing our rectangle like this because remember, summation integration is a Riemann sum. So we're adding infinitely many of those rectangles to get the area. So this basically helps us to see how do I find out my height, right? Remember that this top function is basically y equal to minus x to the third plus 3. And the bottom functions, the line is basically y equal to negative x plus 3. So our height in this case will be what? The top graph minus the bottom graph. And our thickness or the width, that will be what? Since we are placing rectangle vertically next to each other, each rectangle has the width of what? Delta x, which is a little bit portion of x, right? So that's the big, expanding out the picture and looking at it. So not necessarily all the time you will be getting like, a function this good and then be able to sketch or graph it precisely. So what we need to do is we need to know how to learn how to find out these intersection point, which is going to be our limit of the integral. Okay, so that's what we need to know how to find out. So every time in the problems, you need to visualize it. If you can draw it precisely, that's good. If you cannot, sketch it and then find out where these limits, where these intersections going to be. So that will become your limit. So our first step is finding out the intersections of these two, right? Of those graph. So how do we find out, where, x is, which x is going to make these two graph have the same y, these two functions have the same y value? That's all we're going to be doing is what? Setting up those two functions equal to each other. When the y value are the same, what is my x value? So from here, I can basically add x squared on both sides and add 3 on, subtract 3 on both sides. So I got, when I factor it out, I got my x is equal to 0 and x is equal to 1. So you notice that this is what basically we get on graphing precisely. Like again, not necessarily all the time our numbers are this good. So this is a necessary part that you need to know how to, solve it algebraically and then look at it. Is there any questions before I move any further? So the second step that you want to break it down and look at is understanding that this the regions, area of this region is considering adding up all the many rectangles together, like Riemann-sum idea. That's what basically the integral in the formula is talking about, right? So we need to know what is the height and what is the width of the rectangle. So in this case, we already decided to place our rectangle vertically right here. So my height will be what? The top function minus the bottom function. So my height will be negative x to the second power plus 3 minus, okay, minus the bottom functions, which is going to be negative x plus 3. And if you want, we can simplify it a little bit further before we even set it up into our integral. So this will give us negative x squared minus x, and then plus 3 and minus 3 becomes 0. That's my height. So my width is already known after you decided your rectangle is going to be vertical or horizontal. Since we already decided vertically, our width will be what? Delta x, which is basically going to be a dx. And once we got that, then we can basically set up our integral from here. So our integral, our third step will be solving this actual problem now. So our integral area of these regions will be equal to integral from, since the width is dx, we know that our limit will be from x is equal to 0 to 1. So 0 to 1. The height, negative x squared plus a minus x, times with the width, delta x, which is going to be what? Dx. And this is the setup integral setup for the area of this region. Is there any question? So first up, the mistake is a arithmetic error right here that I made. When I distributed negative right here, I forgot to distribute this negative to the first term, which is going to be, this should have been plus x. So make sure we change that. So I change it right here, right? Now, when I start integrating, so integrating the first term, that will give me negative x to the third divided by 3. And when I integrate the second term, that will be x squared divided by 2, evaluating from 0 to 1. So from fundamental theorem of calculus part 2, evaluate the upper limit minus the lower limit value. So that gives us our final answer, 1/6 for this particular problem. So for this problem, definitely we don't want to graph, precise parabolas because that's going to take too much time. But what we know is like the first equation's parabola is opening upward. The second equation, because of the leading coefficient is negative, the parabola is opening downward. So that sort of gives me an idea to sketch it. Here's upward parabola, here's downward parabola. Okay. And this tells us right here, my upward is x squared minus 3x plus 12. And the downward will be negative x squared plus 3x plus 18. So from here, clearly that we know we want our rectangle to be placed vertically. That's the first thing that I see. And second that I need to do is what? I need to find out where these intersections are. Because if I place in my rectangle vertically, right away I know that my width of this will be what? Delta x. So therefore, my limit has to be x, because you are talking about different increments of x right there, delta x. So let's find out the intersections. So first of all, I want to point out that there's a little bit of typo that when I'm typing it up and then the problem go messed up. So make sure you change this into plus x. So therefore, this is plus x. And that will make it nice and neatly on our work right now. Okay. So when we want to find out the intersections, right, meaning the x value that's going to give us 2 equal y value, we set it up the equations. And when I solve for it, that gives me x is equal to 3 and x is equal to negative 1. So this is also going to be our limit. Then the next step is finding out the area of the rectangle, we need the height of the rectangle, and we need the width of the rectangle, right? The width of the rectangle is basically, we got that already since we already decide this is a vertical rectangle. So the width will be what? Dx. That's why our limits is on based off on x also. The height is basically the top function minus the bottom functions that will help us to get the height of it. So at this point, I'm gonna put it this to help you to see, right, what we are talking about. So I'm gonna put my XY axis right here. And when we talk about the height of the functions, that's basically what you are computing from here, x-axis all the way to this. That will be the height of the functions, right? Opening downwards. And then I'm going to be subtracting the height of the bottom function, which is opening upward. So if I subtract that, that will give me here this little portion, which is the height of the rectangle. So once again, that will become what? The negative x squared plus x, right? Okay. Plus 18. And then you're subtracting the one that it is what? Opening upwards, right? The bottom function, which is x squared minus 3x plus 12. And this gives us, when we simplify it, that will be negative 2x squared and plus 4x plus 6. That will be my height. So from here, what we can do is we can basically set up the integral now, right? So our step 3 will be setting up the integral and evaluating it. The area of the region that we're looking for will be integral from -1 to 3, that's our limit. And the height of the rectangle is negative 2x squared plus 4x plus 6. And then the width is the delta x, which is times with dx. Now let's compute this definite integral. So finding out the integrals, integrating integral of the first term, that will give me, you add 1 and then divide by 3. So that will be negative 2/3 x to the third power plus 2x squared, right? When you add 1 and divide it by 2 to 4, that will become 2, and then 6x. Now using the fundamental theorem of calculus part 2 to evaluate for the upper limits minus evaluating the lower limits. That's why we got when I plug it in. And when you use a calculator or by hand, my final answer is 64 over 3. So that's the area of the regions. Let's try another example. So for example 3, after I graph the lines, 2 slanted lines and a vertical lines, x equal to 5 and x equal to 2, you can see that the boundary region is basically two triangle, right? Two triangle shape. One is smaller, one is bigger. And by deciding, we're gonna put in the rectangle, vertical rectangle, right? Using the area of the vertical rectangle to look for the area right here. Then we need to pay attention on the height of the rectangle. So on the little triangle, the height of the rectangle is the top function minus the bottom function, which the top function is y equal to negative x plus 7, and the bottom function is y equal to x plus 1. As in the bigger triangle, the top function is y equal to x plus 1, and the bottom function is y equal to negative x plus 7. So you can see that there is a difference on finding out the height on each region. So therefore, in this case, we cannot formulate it, the area of this total, all the region together under one integral anymore. We have to break it into two integrals. One integral is representing the area of a smaller triangle, and another integral is representing the bigger triangle, area of the bigger triangle. So when we talk about two different integral, then we need to talk about the limit of each case also, right? So you cannot say that the limit will be from 2 to 5 anymore. So you need to know exactly where, the top function and the bottom function, the formula changed it, which means where is this intersections of these two slanted line? That's very important. So let's try to find this intersection point right here, okay? So when we find out the intersections, setting up two formula together, so this will give us x equal to 3. Now, the second part is we need to know what is the height and the width, right, of this rectangle. So for the smaller, for the smaller triangle, so for the smaller triangle, we know that my x will belong to, that's very important. My x will belong to what, from 2 to all the way up to what we just found out, the intersection part, 3. So this is the case 1 case. So in here, we need to know what is the height, and we need to know what is the width. The width is easy because we already decided it will be a vertical rectangle, so the width is delta x. For this case, my height will be the top function. In this case is what? The negative slope of the line minus the bottom function is positive slope of the line. So when we compute this, simplify this, that will be 2x, negative 2x plus 6. So we got, right, the height and the width for this first rectangle. So now what we want to do is we want to look at the second portions. So before that, I'm going to put my start. I will start setting up my integral so that you can see what's going on, right? So my step 3. So my integral, that is basically going to be what my area, the total area will be. The first one is from the first little triangle is 2 to 3. The height will be negative 2x plus 6 times with the width, which is delta x is dx. And then I'm going to be adding with now the second triangle part. So the second triangle is basically starting from my x is belong to 3 all the way up to 5, right? So that's the interval. So that's my limit of the upper bound and lower bound. And in this case, my height, that is basically the top function, which is the positive slope one, x plus 1, minus the bottom functions, which is going to be negative x plus 7. And once again, why are we doing that? Because the height of this rectangle will be what? From here all the way to the top, the height. Take away this little height, that will give me what? In between, the height of it, okay? The height of the rectangle. So if I simplify this, that will become 2x minus 6. And the width, that will be the same as before, which is going to be delta x. So that will help us to get the second integral representing the second area of the second triangle, which is from 3 to 5. My height will be 2x minus 6, and the width delta x, which is dx. And if we evaluate this integral, then that will give us the area of this region. Let's do that. So when I integrate the first integral, you, for the first term, you add 1 to the exponent and then divide it by 2. So that will be negative x squared plus x to the first power. So we evaluate from 2 to 3. For the second integral, integrating the first term will be, you add 1 to the exponent and divide it by 2. So it will be x squared. And the second one will be minus x. And evaluating from 3 to 5. So using fundamental theorem of calculus part 2, first term, evaluate upper limits minus the lower limits. The second term right here, evaluate the upper limit minus the lower limits. And that gives us our final answer to be 5. And this concludes this session, this example. So for example number 4, here's a half of the parabola because we only want from negative 2 to 0 on the x-axis, or for the x intervals, right? And we have here's a line, y equal to x plus 2. And here's a horizontal line, y equal to 0. So therefore, the bounded region becomes this little highlighted yellow part. Now, clearly right here, I want to use you can use it two different ways. If I use this um, vertical rectangle, then what happens is you can see that, right? You can see that up to this point, right? Up to this point, then the rectangle will be what? The top function is a line and the bottom function is a horizontal line. But once we pass this point, what happens is the top functions and the bottom function changes. The top function become a parabola and the bottom function become what? A horizontal line. So that basically tells us this problems I need to use, okay? I need to use two separate integral to find out the area of this, right? So that's one way. Another way is I can think about a horizontal rectangle. Okay? But for the horizontal rectangle, then the problem is not much of a problem. Okay, what we're gonna be looking at is now for the horizontal rectangle. Then what we're gonna be looking at is our top functions, right? Our top functions will be this parabola, and then the bottom function will be what? The line, because that's below the x-axis, right? Y-axis. On the left side of y-axis, I would say. So everything has to be in terms of y now if I'm talking about the horizontal, because this will become what? My dy, right? Delta y. Increment is delta y, stacking up. And another thing that you need to figure out is if I'm solving for y on this parabola, that will be x is equal to plus or minus square root of y. So you need to know which value that you need to, which one you need to use, right? So in this case, it's because of on the left side, then this will become what? We will be using the negative portion of it, square root of y. Right? So that's a little bit more messier to think about it right here, because I cannot use directly like one function and done with it. So you have two choices right here, but we will stick with, I will try to stick with, two, using the two area approach at this point. Okay, so so let's try this two area approach. Okay, so first let's find out where this intersection point is. So when we're looking for the intersections, setting up those two y value equal to 0, so it will be x squared equal to x plus 2. And then when we solve for this quadratic, we got x equal to 2 or x equal to negative 1. Since we are only interested in from 0 to negative 2, x equal to 2, we don't have to worry about this intersection point. It's because we are only interested in this region right here, right? The shaded area. So, and now I'm placing the purple rectangle and then blue rectangle, because you can see that the height of those rectangle will be using different functions. So for the purple rectangle, that's basically from negative 2, x is equal to negative 2 to negative 1. Okay? So that's our limits, lower limit and upper limit. The height for that rectangle in this interval will be the upper functions, which is going to be the line, and the lower function is this horizontal line, y equal to 0. So the y value on the top will be x plus 2. And then the y value for the bottom part will be 0. So therefore, when I simplify it, that will become x plus 2. And the width is delta x. And for the second part of this, blue rectangle part that I drew it, the interval will be from negative 1 to 0. And the height of this rectangle will be the height of the function, which is this y value. That will be represented by x squared. And then the height of the bottom function, which is going to be what? Y equal to 0. So it will be always equal to 0. So now we're going to be simplifying, and then the width will be the same thing, which is delta x. So our step 3, the area for this region will be area from negative 2 to negative 1. The height of that will be x plus 2 times with dx, plus integral from negative 1 to 0, that's the second region, 0 to -1 to 0. And the height of that will be x squared times dx. Now let's evaluate this integral. So integrating each part. For the first one, you got x squared divided by 2 plus 2x. And evaluating from -2 to -1. For the second integral, when you integrate it, that will be x to the third divided by 3, evaluating from -1 to 0. Using fundamental theorem of calculus part 2, evaluating the first integral, adding with the value of the integral of the second integral. And this gives us 5/6, which is the area under those curve bounded. Let's try example, last example. So example number 5, x equal to y squared plus 2y, that's parabola opening the sideway. Okay. Parabola opening sideway. And then x equal to y plus 20, that is a line. Okay. And let's say that we have a line like this. I don't know, I'm sketching it, right? I'm sketching it. So that's basically tell me, right? At this point, I can place my rectangle vertically. But if I place the rectangle vertically, then I'm going to be having what? The top functions and the bottom function is basically what? On the same curve, the same functions right here. So that would be a tougher for us to, add and subtract things. So that's something that we want to avoid it if we can. And also, another thing is what? Even though we can do that at this particular point, after this particular point, this rectangle will have two different functions. The top functions is a parabola, and then the bottom function is a line. And you need to choose the top functions, like, how do we use the positive part, the negative part, or the whole thing. So that makes it a lot more problematic on the vertical rectangle part. So for this particular one, and what we want to do is we want to look at a horizontal, right, rectangle idea. So if you use the horizontal rectangle idea, then my width will become dy. So what we need to do is we need to know the limit of y, right? Before we are using dx, so we have the limit of x, where x is from where to where. So that way we can stack up the rectangle vertically all the way up to what, x. For this one, it will be dy is my width. But also the good thing about it is what? The height. The height of the rectangle will be what? This line minus what? This parabola right here. Okay? So that's how we can look at it. So here's the parabola. Y equal to x equal to y squared plus 2y. Okay? And then the line is x equal to y plus 20. So now let's try to, set up this. First, what we want to do is we want to find out where are my intersections, these points right here, the y values are. Because now we are looking at, here's y-axis, here's x-axis in these directions. I did not draw like, xy axis because I don't know this parabola opening upward is all the way on the right side of x, or a portion of them is on the negative part of the x. Okay. You can find out that by like, solving the intercept on this equation, but that's not our goal. Okay. So for this particular one, let's find out the intersections. So for the intersections, when we set it up two equations, we got my y value to be 4 and -5. So that sort of gives us what is our limit is. Now we want to talk about height and the width of the rectangle. The width is easy because we already decided it will be what? A horizontal rectangle. So the width will be dy. And how do we decide the height? The height is basically, the top function minus the bottom functions. So when we look at how do we decide, like, which one's the top one, which is the bottom one, if you look at this way, my xy axis, the larger the positive value, the larger the x positive value, that's going to be my height, because that's where it's going from this y-axis, right? And the smaller the x value, that will be what? The lower functions. So that's how I decided the upper functions and lower functions on this sideway part. So that tells us my top function will be y equal to 20, y plus 20, right? That's my bigger x value is going to be. And then my smaller x value will be what? Y squared minus y squared plus 2y. So when I simplify it, that will give me negative y squared minus 20, minus y plus 20. So to set it up the integral for this area, so this time we're going to be looking at the area, right, is equal to integral from here, -5, my y value, all the way up to 4. And the height will be negative y squared plus minus y plus 20. And then times with the delta x, the width, which is dy. And now let's take this integral. Integrating this polynomial. So first term, add 1 to exponent and divide by 3. Second term, add 1 to the exponent and divide by 2. And then the last term will be 20y. And we're going to be evaluating from -5 to 4. So fundamental theorem of calculus part 2 said that evaluate the top limits, upper limits, minus the value of the lower limits. So we got 729/6 as our final answer. And this concludes this section.